Okay, so just to go through a question from exercise 3.8, I'll go through question 9. So we have a curve here. Okay, we're going to try and work out what type of curve. Is it sine or is it cos? We've got to find out where the midline is, what the period is, i.e. how squashed or stretched out it is, sort of horizontally, and then as a result we should be able to come up with the actual equation. So I suppose the first thing is we can see where the midline is, halfway in between the maximum value of 4 and the minimum value of 0. Okay, is the midline of 2. So the midline, the equation we would actually write y is equal to that number, y equals 2. Okay, so we know that the whole curve, whatever sort of curve it is, it's been raised up 2 values from the x-axis. So the whole thing has been moved up vertically. The next thing is we need to appreciate is its amplitude. We can see that, I know we haven't been asked the amplitude, but we'll need it for the last part. We can see the width of it, the height of it, I suppose, above the midline is 2. Okay, so the amplitude is 2. That's my midline. That's another important piece of information. So let's just go back. Okay, it's starting at 4, right? Okay, so that the amplitude is 2, so that's why it's 2 up from 4. But if you imagine if this was my x-axis and that was not 2 but it was 1, be crossing at 1, you need to realize that the cosine curve does that sort of U shape. Okay, and the sine curve does a sort of an S shape. And you need to know that one starts at 0, 0, the sine curve, and the cos, that U shape ending up back up at 1. It starts at 1 on the y-axis. Okay, so sine starts at 0 and cos starts at 1. You just have to learn those two. Okay, so I can see here that it looks like the cosine curve there, that U shape. Okay, I know it's not starting at 1, but we can understand why it's not starting at 1. The whole thing has been moved up 2, and it's been stretched by a multiplier of 2. Excuse me. So the next thing is the period. So what we want to appreciate is the width of it. Okay, so let's just use a different color. So if we look at the width of that, what is the width of that? So the width of it is pi. Now you need to appreciate that the normal width of these standard curves is actually 2 pi, okay? Again there's 2 pi, i.e. 360 degrees. So this is half of the normal period, okay? So the period is literally just is equal to pi, okay? It's a width of for one full oscillation before it starts repeating itself. Now, because that's pi, and originally it was 2 pi, in a sense it's been squashed, okay, and the squash is a sort of not a multiplier, but it's a completely untechnical term, squash, but the horizontal squash, okay, it's been squashed by a factor of 2. It's been halved. Okay, so the squash is a factor of 2. So as a result, it's a cosine curve. So my function, okay, let's call it f of x is equal to, now I know it's cosine, and because it's been squashed by a factor of 2, it's 2x. Okay. In terms of its amplitude being a height of 2 rather than a height of 1, I know there's a multiplier out the front, and I suppose different color again. This midline here, because it's been moved up 2, okay, that's why I have a +2. Now, whether I put the +2 in front there, okay, or whether I put it afterwards, it doesn't really matter, okay? Usually put the number at front so that people don't think it's part of the function, okay? So we just leave it. We leave it out in front. It wouldn't matter if you had it at the end. Moving on to the next one, the same process, I can see that halfway in between my maximum value and my minimum value, okay, is the line, the midline y equals to -1, okay. If I carry on and appreciate the amplitude of it, okay, the amplitude, okay, so how much has been stretched vertically, that distance there is 3, okay, so I know it's a multiplier of 3 as an amplitude. And then I want to look at the horizontal, sort of what's going on horizontally. So if we consider the fact that it seems to go through a whole process, a cycle in 0 to 4 pi. So I know my period is 4 pi. Therefore, my squash, okay, in a sense, it's counterintuitive here. It's actually a stretch. So in a sense, I'm only getting a half of the oscillation done with inside 2 pi. Much like this one here, I get 2 oscillations in 2 pi, and so it's 2 times 2. Here my squash, because I only got half of an oscillation within 0 to 2 pi. Now, lastly, identifying the type of curve. Again, it's about thinking about the cos and the sine. Now, it doesn't seem to be either of those. It doesn't seem to be this U shape. It doesn't seem to be this S shape. But what it doesn't do, it doesn't start at, in a sense, this intersection of the y-axis and the midline. Okay, so it's not that S shape of the sine. Okay, so therefore it must be cosine, but it's upside down. It's a cosine curve. It's that U shape, but it's upside down. So what we realize is, as a result, is that effectively this is upside down. So we've got I suppose, a multiplier of -1. We get that reflection. Okay, so when we're dealing with the amplitude here, we have to appreciate that the whole thing is negative. Okay, so that's going to actually be -3 as an amplifier. So my function as a whole is going to be f of x is equal to, now it's cosine, but it's an upside down cosine, right? Okay, so well, we'll do that in a second, right? The squash, the period is 4 pi, so the squash is only halved as such. It's been stretched, in fact. So my horizontal stretch or squash goes inside in with the angle. The amplitude vertically goes in front of the cosine curve. It's -3. And lastly, it was moved down. The whole thing was moved down by 1. So therefore, my number in front is -1. So that's the process. Well, what we're doing is we're trying to identify a number of different things. Effectively, you've got several things going on. You've got how much the whole thing has been moved up and down. That is informed by the midline. You've got how much it's been stretched vertically. So that's informed by the amplitude. You want to know how much has been squashed horizontally, and to tell you that, you want to know how many oscillations you get in 0 to 2 pi. And lastly, you've got to appreciate what the type of curve is it sine or cos, and whether it's upside down or not. Okay, that'll tell you your polarity. So it's 5 pieces of information in total. I hope that's been of use to you. Get back to me if you have any more questions.